So in this video, I'm going to look at finding the derivative using something other than equations, because we know the rules to pretty much any equation now. You should be getting to where you can find the derivative just by applying the right rules. But we also have, so this is going to be looking at the quotient rule, product rule, and chain rule without equation, but looking at a graph instead. And so this will help cement your understanding about what a derivative is in terms of the graph. And also, I think it really helps kind of make it clear how the product rule, quotient rule, and chain rule work. So this is the graph of f of x, and the second one is the graph of g of x. And so we have this other function down here, h of x, which is made of f times g. So if I wanted to find the derivative of h of x at a certain point, let's say at 1, for example. Well, first of all, I know that it's f of f times g, and the only information we have is about f and g. So first thing I'd want to do is think about the derivative of h of x, of course, would be, well, the derivative of h of 1 would be f of 1 times the derivative of g evaluated at 1 plus g of 1 times the derivative of f evaluated at 1. So that's just applying the product rule. So then when I go to do this, when I'm going to get my values, of course, I don't have an equation to plug them into. I just have to go back to the graph to find them. And of course, f of 1, that just means I'm plugging in 1 for x, and what do I get out for y? I get out 1. So this would just be 1. G prime of 1, that means I'm going to the g graph, and I'm looking for the slope at 1, because remember, derivative is slope. So at 1, that would be right there. What's the slope of the graph there? Well, fortunately, it's a straight line, so I can tell the slope because it's a constant slope all the time, and the slope is 1/2 there. So this would be 1 times 1/2. And then g of 1, when I go over to g of 1, I plug in 1, I get out 1, because now we're looking for a y value because it's not a derivative anymore. And then here, f prime of 1. So when I go to 1, I'm looking at that point right there, and it's asking me what's the slope at that point. Well, clearly the slope is 0, so that would be times 0. So then this would just be 1/2. So the derivative of h evaluated at 1 is 1/2. Okay? Likewise, when I find the derivative of n, that's going to be the quotient rule. So that would be low. Whoops. Let's do it at 2 just to spice things up a little here. So that would be low. That would be g evaluated at 2 times low d high. So that'd be f prime at 2 minus high f of 2 times d low g prime of 2 all over g of 2 squared. So again, I'm going to go to the derivative to find out these values. G of 2, that means I'm going over to the g graph and going out 2, and that would be 1/2. So that's going to be 1/2 on top times f prime. Whoops, the prime got lost in there, didn't. F prime of 2, so I'm going back to the f function. And at 2, what happens at 2 there? Well, the function's undefined. Or not the function's undefined, the function's defined, but the derivative is undefined because there's a sharp point. We call that a cusp, right? So that would be undefined. Well, then we wouldn't go any further, right? So let me change this so we're actually can get an answer here. But the answer to that would be undefined. So let's do it at 3. That would be fun. This keeps going. We'll do it at 3. Okay. So g prime of 3, that's still 1/2, isn't it? oh, that's not supposed to be g prime of 3. Whoa, man, this is messing me up. This is just g of 3, isn't it? Because it's low d high minus high d low all over low squared. Yeah. So it's just g of 3. Well, g of 3 should be 0. Sweet. F prime of 3, that would be right there, which would be 1. Of course, it's multiplied by 0, so it doesn't really matter, but I'm going to put it anyway just so we can see it. F of 3, that would be 2. And we're going to multiply that by the g prime of 3. Well, g prime of 3, that would be the derivative right there, which is the slope, which would be 1/2, all over g of 3 squared. Well, g of 3, once again, is 0, so that would be 0. So this is going to be 1 minus 1 over 0, which is actually undefined again. Wow, everything looks like h is destined to be undefined. Okay. So there's example of product rule, quotient rule. Now let's do example of the chain rule here. So once again, the chain rule tells me that I take the derivative of the outside first. So that'd be f prime, but I leave the inside alone. Oh, let's pick a number we're doing this at. Let's do m prime of 1. So that would be f prime of g of 1, right? Not g prime of 1, but just g of 1, times the derivative of the inside. That would be g prime of 1. Okay, so first thing I'm going to do is find out what g of 1 is. Well, g of 1 is 1, so that means we're finding f prime of 1 times g prime of 1, because this was just replaced with 1, because that's what g of 1 is. G of 1 is 1. Okay, so then I go to f prime of 1. Of course, that's over here, f prime of 1. That's the derivative there is 0, right? And it doesn't matter what g prime is, but I'm going to do it anyway so we can see how this works. G prime of 1 at 1, that would be right there. The slope, because that's what derivative is, the slope. Slope would be 1/2, so I would put 1 over 2 there. But of course, 0 times 1/2 is 0. So the derivative of m at 1 would be 0. Okay, so, and this would work the same way if I had a table of values. I would be going to the table to find out what g was. But the key is writing out the product rule or the quotient rule or whatever you're using so you know what values you're looking for. So you know whether you're looking for a derivative or a y value. Okay, have fun.